Okay, dear students, let us discuss one more problem on engineering mechanics. Problem set 2.4 and solution to 2.46. The statement of the problem goes like this. A roller of weight, the force due to gravity, right, on its mass is 4450 Newton. It rests on a smooth inclined plane. If you look at the figure, this plane is a smooth inclined plane, means there is no force of friction at the point of contact B. Is kept from rolling down, means it is not rolling down, it is kept fixed due to a string as shown in figure D. Using the method of projections, find the tension S in the string and the reaction RB at the point of contact B, right? So there is no force of friction. So what is given is given the weight of this roller from the center of gravity from this point downward, as it is shown here, is W, and the value of W is given as 4450 Newton. And AC is a string making angle 15 degree here, and it is holding back this roller from rolling down. Right. So since AC is a string, then there will be an axial force in the string called the tension force, S. It will be acting away from the point A and point C. Means this string will have a tension, let it be S. If you consider the point A, it is to this side. If you consider the point C, it is to this side, let it be S. And at the point B, this roller, due to its weight, the weight is vertically downward. A part of the weight will be acting to this side, called the action force. So there will be a reaction force to this side at the point of contact, right? Let that reaction force is RB. And as you know, the reaction force is always normal to the surface. This is the surface, and this reaction force RB at the point of contact B is normal to the surface, right? Means making this angle as 90 degree. So we have to find this reaction force RB and the axial force, the tension S, developed in the string AC, which holds back the roller from rolling down. So I have drawn another diagram for you here. If you look at the same diagram is drawn again here. So let me explain it. At the point of contact here, called B, this is the reaction force RB, which is passing through the center of mass of the roller, and it is pointing to this side, let it be RB. And this angle is given as 45. And this point is A. This is your string, right? And it is also given this angle is 15 degree. This is given 15 degree. So this is your horizontal. If I draw a horizontal line, this dotted line passing through the point A, then this line is a transversal between these two horizontal lines. So if this angle is 45, then this will also be 45, alternate angles. Now, since this is 45 and this is given as 15, so 45 minus 15, I am left with a 30 degree. So from here to here is 30 degree, right? So means the axial force, the tension force is makes angle 30 degree with the horizontal, right? And then I have drawn another diagram for you that is called the free body diagram. Now the question is, this angle is given as 45. Then the question is how this angle is 45. The weight is vertically down, acting downward W. So therefore this is 90, this is 45. So obviously this will be 45, but I have not written it. And this angle is vertically opposite to this, so this will be equal to this. And this is the normal reaction RB at the point of contact, so this angle is 90. And this is these two angles are equal, being vertically opposite. So if you compare these two triangles, this triangle and this triangle, 90 here in this triangle and 90 here in this triangle, and this angle is equal to this angle. So the remaining angle of this triangle and this triangle will be equal, and the remaining angle here is 45, so this remaining angle will also be 45. So once that is understood, let me draw the free body diagram at the point C, where there are three concurrent forces. So if you look at this diagram, I have drawn x-axis passing through the point C here horizontally, x-axis, and this is your y-axis, right? Now the question is how this angle is 45. How this angle is 45? If you extend this line, the line of action of the weight to this side, then this 45 which I just explained is vertically opposite to this. So this will also be 45 degree. So that is what I have shown here. So the reaction force RB makes angle 45 with the y-axis. Now if you look at the tension force, axial force, the tension force S, which I have shown it here, it is acting away from the point C. How this angle is 30? Now, how this angle is 30? At point C, if you draw a horizontal line, like this dotted line is also horizontal, this red line is horizontal, this line AC is the transversal, this angle is 30, therefore this angle will also be 30, alternate angle. So that is what I have shown here. So now we know this angle 45, this angle is 30, that tension force X moves with the x-axis and the weight is vertically downward. Now then it is very simple. So since this weight is along y-axis, this does not have a x component. This RB is making some angle with a y-axis and some angle with x-axis, that is obviously 45. Because this is 45, this is 45, and x-axis and y-axis are perpendicular, so together they have to be 90. So we can resolve RB into rectangular components, means from here if you drop a perpendicular, from here to here will be RB cos 45, and if you drop a perpendicular here, means if you find the projection of RB on x-axis, from here to here will be RB cos 45. Similarly, the tension force S developed in the string making angle 30 degree with the x-axis. If you drop a perpendicular from here, then from this point to this point, that is this one, will be the projection of the tension force S along x-axis. So this will be your S cos 30. And if you drop a perpendicular here, then from this point to this point, this will be the component of the tension force S along y-axis, and since it is in front of the angle 30 degree, so from here to here will be S times sine of 30 degree. So we have resolved RB and S into two rectangular components along x-axis and y-axis, and this one is already on y-axis. This does not have an x component. Since the system is in equilibrium, then we have to use sigma x is equal to 0 and sigma y is equal to 0, means sum of the forces along x-axis 0 and the sum of the forces along y-axis is 0. So that is what I am doing in the next page. Now that is what I have explained. W, the weight, does not have any component along x-axis because this is already along y-axis. Therefore sigma x is equal to 0 for equilibrium. So sigma x means sum of the forces along x-axis. So if you look at here, the tension force has the x component to this side from C to this point. That will be S of cos 30, S of cos 30. And the component of RB along x-axis means from this point to this point will be RB cos 45. This is opposite to this. And if they're equal, then only they will cancel. If they're equal in magnitude, they will be cancelling. So the net force will be 0. So I have made them equal. So I bring sine 45 to the left hand side. So I am left with S cos 30 over sine 45. So sine 45 is 1 over root 2, cos 30 is root 3 over 2. If I put it in a scientific calculator, this comes out to be S times root 6 over 2. Put this in a scientific calculator, this comes out to be 1.2247 times S. This is the reaction force RB. That is what I have written here. Now let us go for sigma y is equal to 0, means sum of the forces, the vector sum of the forces along y-axis is 0. Now if you look at this, W is vertically downward along negative y-axis. And the component of this S along positive y-axis will be S times sine 30. And the component of RB along positive y-axis will be RB times sine 45. And they will be added and their numerical values should be equal and opposite to W, so that both of them cancels and net force is 0, therefore it is in equilibrium. So that is what I am doing in sigma y is equal to 0. S sine 30 along positive y-axis, RB cos 45 along positive y-axis, W along the negative y-axis. So don't look at this part. So now I do it like this. S sine 30 remains as such. For RB, which I just found out as 1.2247 times S, I have put the value of RB here. A cos 45 remains as cos 45 and the value of W is given. So I take S from here and here as common. So I'm left with sine 30 1 by 2 plus 1.2247 times cos 45 1 by root 2 is equal to 4450. So since this factor is multiplied with S, I take it to the right hand side, it will be divided. So I have divided here. Put it in a scientific calculator. These values are all numerical values. So this comes out to be 3257.701 Newton. That is the value of the axial force developed in the string called the tension S. Now once you know the value of S, you can resubstitute it here to find RB. So your RB is equal to 1.2247 times S. Now I put the value of S and do it in a scientific calculator. This comes out to be 3989.707 Newton. So there are two answers, and the axial force tension is found out and the reaction at the point of contact B is also found out on the roller.